So hierarchical time stepping, the implementation is to take advantage of both MPAS feature of having smooth transition of resolution and avoiding the abrupt change of resolution in the domain nesting boundary, and also take the approach that refinement region use a smaller time step and the coarser resolution region use a coarser time step, putting them together. Our usual practice is using a factor of 2 instead of Wolff's factor of 3. So in the implementation, we have some overhead because for the boundary between the final resolution area and the coarser resolution area, there is a buffer region that unavoidably the computation for both the final time step and the coarser time step both need to be carried out, and then our implementation will let the simulated results in the fine region and the coarse region to influence in both ways. In Wolff, we say that it is two-way nesting, so which is natural when you put to the variable resolution and structural mesh. And having paid its overhead, the outer coarser region is free to use a longer time step, and we can do it hierarchically. So this implementation in this CPAS platform. For the space discretization technique, there will be just 2 slides left before we can go to the lab. We provide you a user interface. You can specify the shape of the refinement region and the target resolution. And if you actually press this button to export this mesh specification, spec means specification, to a file, this file is actually just a JSON file in a GeoJSON format, and then you can share it with your teammate. So the essence of this tool is for you to spend resolution at where you want and avoid spending resolution at where you don't intend to. And there is some added feature in these tools. Here, you specify target resolution, and below it, there are 2 options: boost orography and boost coastline. Sorry for the brevity. This may not be grammatically correct, but we want to use fewer words in the graphical user interface. For orography, I have introduced the wind, the dragging or blocking effect of wind can better be taken care by boosting the resolution. So this tool will try to look up the terrain data and have some rule to find out areas that the terrain height changed significantly, and then automatically assign a final resolution like boosting from 16 kilometer grid spacing to finest 4 kilometers, but that will spend a lot more computational cost, but it save your work in manually look up the mountains and draw the polygons to surround the mountain. Try to do it automatically for you. And for coastline, so if you intend to use the atmospheric simulation to simulate phenomena like land sea breeze, which is greatly affected by whether the model can represent the coastline accurately. And also, if you want to simulate the diurnal temperature change at a location that you need to differentiate whether that location is actually on land or on water, then you need to use higher resolution to areas around the coastline. So you can use this boost coastline option for the tool to look up coastline data for you, it actually look up the land use or the sea, the water and the soil data, and detect the boundary, and then boost the resolution for the area near to it. Sometimes maybe even river can have an advantage of being boosted with final resolution. So here is the feature, and this is one example of the resulting mesh if you use the feature.